Hello everybody on the Dart language tour. We've come quite a ways and we are today talking about lexical scope inside the functions section. It started getting a little tricky when we started talking about first class objects, anonymous functions. Lexical scope and closures are going to kind of go hand in hand. But we will stick with scope as its own video because I think there's going to be enough material to warrant it. Okay, so let's try to get through this. The first thing is just like the very first word you encounter in this section, lexical. What the heck does it mean? Okay, I've already Googled the lexical meaning relating to the words or vocabulary of a language. So if something is scoped lexically, it has lexical scope. I guess it's like the variables inside a function is how I think of that. These words that describe objects like integers and strings, or maybe other functions inside of a function. That can be an object as well. Okay, you can tell that lexical really didn't get a lot of use until computer science came onto the scene. All right, so there's this big jump over time, uses over time. Okay, so that's what lexical is about. It's like relating to the words, I guess. I try not to think of the word lexical because I'm not a computer scientist. I'm just a programmer, a web developer, hopefully aspiring Flutter developer. Just know what it means and know that people use this in the terms of scope and closures, or like functions and variables. Okay, so that's kind of the cloud, the word cloud that it lives in. And then scope is the degree to which something has application. For example, does this variable apply inside of this function? Well, yeah, by default it applies here. It's relevant because it's defined inside the function. Outside the function, it would be irrelevant. The program wouldn't know what inside function is if it were defined somewhere else, or if we try to use a reference to it outside of where it's defined. It would be irrelevant. It is not scoped there. Conversely, anything that's global or top level, the rest of your program will know about it. It will have access to use it, so you can print top level all the way down in here. We might show this a little later. Okay, so that's kind of the idea behind scope, is like, where does the function live and where does the program, the overall program, know about it? You know, in here where it's defined, what about where it's nested, what about its parents, and so forth, and further up the ancestor tree. Okay, so Dart is a lexically scoped language. Another word you'll hear people use is statically scoped. It's not like statically typed, it's statically scoped, meaning that the scope of the variables isn't going to change based on how it's used, I think is the gist there. Instead, it's when something is lexically or statically scoped, it is intuitive based on how you read the function. By intuition, I know that when I call my function, that inside of there's going to be a variable that I can use in other places. Okay? That's why they say here, simply by the layout of the code. All right, so you can follow it visually as a human. The scope of variables is determined statically. You can follow the curly braces outwards to see if a variable is in scope. So, so it's inside these curly braces. If I go follow the curly braces outwards, it's no longer in scope there, this one in particular. Okay, here's an example of nested functions with variables at each scope level. Okay, so you have your entry point main function, there's my function, here's a nested function. and there's variables all along the way, including at the top level outside of this main function. So notice how nested function can use variables from every level all the way to the top level, or all the way from the top level. It can use them. So yeah, this is literally the Dart section on Lexical Scope. If you're kind of used to programming, it's almost not worth mentioning because it's so obvious simply by the layout of the code. If you are new to programming, it might be a difficult concept to grasp. So it might help to see what dynamically scoped code looks like and what you would expect. Okay, I was thinking when I was preparing for this how I would think of this term, because lexical is so new and so computer sciencey. Anyone without a computer science degree might, that the word lexical is just a big distraction or a turnoff. And the word I came up with is affixed, which unfortunately is also used to be used a lot but is no longer used. So if you haven't read any books from the 1800s or prior, then you might not know what this word is either. When something is affixed, he licked the stamp and affixed it to the envelope. Another word is like attached. So I tend to think of the variable, like this one here, inside function, it's attached to this function. It is affixed or attached to it. Outside here, the inside function is not attached to main in that sense. So even though it's nested in here, the scope is really just inside these curly brace blocks. Okay, I think even that one, yeah. Okay, so that's another way to think about it if you find that confusing. There is a very good, a very detailed Stack Overflow post called "What is Lexical Scope?" asked 12 years ago. There's a lot of comments, and the one I want to focus on is the one that was selected as the correct answer, even though it's written in a C-like syntax and not JavaScript. Okay. Lexical Scope, also called Static Scope, looks something like this. This is what we just saw in the Dart language tour. Okay. So every inner level can access its outer levels. So they're using that same terminology about outer or outwards, the levels or outside of curly braces. Okay. The other way, called dynamic scope, this was actually how things were scoped back in the first implementation of Lisp, apparently. And this is what it would look like. So you have your fun function. Here's the logic for it. Okay, they put this on new lines. Some people like to do that instead of having the curly brace start on the first line. It's saying print this in a formatted way, whatever x is. And you'll notice there's no variable in here called x. There's no parameter that you're asked to pass in when you call fun, like down here. Instead, they are defining x in these functions called dummy1. Okay, so there's the name right here. Here's the block of code. It calls fun, okay? It knows about fun because fun is defined up here. It knows about it and can call it. And then dummy2 does something similar, except it defines x as 10. And because it's dynamically scoped, this supposedly can work in theory, because fun, instead of being statically scoped, where x would need to be defined herein in the fun function or passed in when you call it, it's dynamic. So whether you could have dummy1, dummy2, dummy3, dummy4, all these functions where dynamically they set the x value, and then because fun is also wrapped up in this block together, it should know what x is. So the first one, it gets x equals 5. Okay, it runs fun. and then x should be should be 5. It should print it like that, right? And this one should print 10. Dummy 2 should. But if we try to do this in Dart, it's not going to work. And I've already pasted it over here in the code. Okay, so this is the Dart version. You have fun, you have dummy 1, and dummy 2. Because fun prints something, we actually have to call dummy 1 and dummy 2 down here to get it to print. And this is from earlier, disregard this. This right here, right now, it says that x is undefined. That's because we haven't set a variable called x, and we haven't said, oh, pass in a variable when you call it, like that. So now we're like defining x there or there, and that satisfies it. Okay. So dynamically, Dart doesn't even allow it because Dart is statically typed. Okay, so we would have to either, if we wanted this to work and call fun, again, we would either need to pass in the integer x, in which case, let's see, yeah, you could do it like so. This is ridiculous. X, okay. So in each one, we're defining it, okay? So when we run this, we should get 5. So dummy 1 prints 5, as we would expect. We're passing it in. Dummy 2 prints this. So x is statically scoped to dummy 2, and we've updated fun to accept the value. If we wanted to instead define x here, okay, so now there's a variable inside of fun. It doesn't take any parameters. We don't call it with any arguments. Instead, let's say we give it an initial value of 0. Inside here, maybe we can redefine x. No? Okay, let's do this. Let's see what happens. It's telling us that x isn't actually used. So even though we're defining x here, because we set x in the fun function itself, it's going to print 0 in both cases. Okay, just like that. Something we could do is we could define x up here. Okay, let's give it an initial value of 0. Let's get rid of this. Now fun can be called because here, these things are all siblings. The fun function, the declaration of x, dummy, and dummy 2, they're all siblings on the same level, so they know about x. I could get rid of, or just comment these out. So now dummy 1 and dummy 2 just calls fun, and because fun knows about x, okay, it can see it from the outside, I'm able to run this, and so it should print 0 and 0 again. Now if I wanted to override this, I've already declared x as an integer, so now I just want to update it. Okay, so now when dummy 1 is called, even though x is defined as 0 out here, locally it updates that same variable. So now these are referring to the same thing. It updates it to 5, so that should print 5. Okay, same thing with this one. I can update it to, and here's the deal. I think because if you read this top to bottom, x is 0. This is where fun is defined. Fun for the first time is called in dummy 1. So when we call dummy 1, x is going to be set to 5. If we don't reset it to 10 or something else, it'll be 5 here as well. So I think we'll get 2 5s. All right, just like that. If we want to uncomment this line in dummy 2, now this is getting reset to 10, and so we should get 5, it resets it to 10, so we'll get 10. And if we just wanted to call fun by itself, x should be 10 now. So we'll get 5, 10, 10. Let's run that. Okay. So notice we had to have the x declared before fun so that it would know about it. So again, there is scope. Static scope is built this way, where all the top level stuff is accessible when you get nested further down. There's that type of scope, but then there's also top to bottom scope. It's not going to compile it and say, oh, I know about x. Yeah, obviously it's in the file, it's in this function, I should know about it. It actually has to be declared right there at the top. Okay, non-nullable must be assigned before it can be used. So this is interesting. We do get a compilation warning. Even though this is where it's defined, we're not using it yet. Even though I'm updating x to be 5 here and 10 there, let's see if I get rid of this, if that'll be okay. It still doesn't like it because it's not. Okay, so there's my optional. So we're saying x can be null when you define it. Like if I wanted to call fun immediately, I would get null. It would print null, right? Okay, just like that up top. If I left it like this, I get that error again. I could give that a bang, I think. No? Can you not do that? Will have no effect because the receiver can't be null. I wonder if we gave it like a default value, like an empty string. No. Okay. I tried to play around with it. Then we'll just leave it at that. If we wanted to use it like so without declaring it, with a value, we could do that and say, trust us, we're going to define it later. Okay. So this has been a little more involved. We looked at what dynamic scope would look like. We saw that Dart doesn't allow it because it's statically scoped. And then we played with how to actually use functions correctly by making it statically scoped and using our two methods. Okay. If we want to look at this example itself, we can update. Did that have main? Yes, it did. So I'm going to select everything. Now this will run, but these functions are actually never called. Nothing's printing. So check this out. I think I can do this. There we go. That's cool. So now I can print these things. So when nested function is called, it'll actually print the values of this. So let's do that. Let's call nested function, and I'll just be super verbose about it. Dot call. I don't know if it'll actually get reached though. No, it won't, because what I have to do next, after my function is defined, which is all this stuff, I actually have to call my function. Okay. So now when I invoke an instance of that, this will suddenly be defined. This function will be defined. When it calls it, this will be defined, and it'll print all of these things. That's how my mind understands it anyways. Okay, so down here in this most nested level, this top level, it knows it's true. Inside main, it knows it's true. So forth and so on, because at the most nested level, it knows about everything above it. But outside of that, that's not the case. For example, inside nested function, if I wanted to print inside nested function, that variable, it's not going to know about it. It gives me a warning. Try correcting it to one that is defined or defining the name. Okay, so my program won't even run. And that is the beauty of Dart and compiled languages. Cool. All right. That, I think, is going to be it on lexical scope. We will go into more depth in lexical closures, where we will apply that idea of the static or lexical scope. All right. If you have any questions or comments, leave them in the comment section and I will give them an answer. Thanks.